We're going to take a look at this equation written out in number 44 and graph that as a line. And there's really two options that we've talked about in order to take some kind of equation like that and graph it. And one is to manipulate that so that it looks like this slope-intercept form, or excuse me, point-slope form, or to take that equation and manipulate it until we get into a y-intercept form. So we've got two options so that we can put it on the graph. Eventually, by the way, our graph should look kind of like that. That's what that initial equation is, 3x minus 2 equals negative y minus 4. So I should be, if I want to double check and do it on a graph and calculator, it'll end up looking like that. So let's look at those two different options, and either way would be fine. If I was going to do it this way, where I'm trying to get down to this point-slope form, you'll notice the y's need to be on the left, the x's need to be on the right. So the first thing that I'd probably do is just switch those two around. Negative y minus 4 over here equals a 3 times x minus 2 on that side. Okay, we're already pretty close to this format where you've got a y minus something, except for the problem is we've got a negative y. So what I'm going to do is I'm going to divide both sides by negative 1. And what that ends up giving me is y minus 4, or excuse me, y plus 4. And that's set equal to a negative 3 out front times the x minus 2. Okay, so that is my point slope form. And if I were to graph that, I'm going to graph it over here, just freehand on this grid. I know I've got a point here that must run through 2, negative 4, right? Because this is y minus a y I know, this is x minus an x I know. Well, the x is 2, the y is going to be a negative 4. So I can go over here and say x of 2, y of negative 4. The line that I'm graphing is going to go through that point. The only thing else I need to know is that it's got a slope of negative 3. So a rise of negative 3, a run of 1. Down 3 over 1, down 3 over 1. Okay, so I'm going to get a line that looks something like that. Okay, that's how I would graph it if I had changed this thing into point slope form. The other option that I told you about was to put it into y-intercept form. And if I was going to do that, again, I've got my y's on the left, my x's on the right, so I'd probably just start by flip-flopping that. We'll call that negative y minus 4 on that side. Bring the 3 times x minus 2 on the other side. I want to kind of spread this out here. I don't want anything in parentheses. So the next thing I would do is just distribute that 3. We'll call it 3x minus 6. And now I want y by itself here, so let's add 4 to both sides. If I do that, I'm left with negative y. If I add 4, that becomes 3x minus 2. And then the only other thing I need to do is multiply by negative 1 on both sides. Or you can think of it as subtract or dividing by negative 1 on both sides, either one. That'll get you y by itself. And then over here we'll have a negative 3x plus 2. And now I'm in that, in the y, or excuse me, slope-intercept form. So again, if I was going to graph that, I've got a couple different things. I've got a y-intercept here at 2, so it'll go right there. And I've got a slope of negative 3, which makes sense because it should match up with the other way that I wrote this equation. These equations are essentially the same thing. So from that point, I've got a slope of negative 3, down 3 over 1, down 3 over 1, down 3 over 1, and so on. And there's that same line that we got, which is the same line that we saw when we used the graphing calculator.